Hello, ladies and gentlemen. Welcome to week 4, lesson 2. We are on topic 7, lesson 1, and on textbook page 347 to 348. As always, let's start with the quiz. What are two gases that contribute to the negative greenhouse effect on Earth? I say negative because the greenhouse effect without humans works fine. Unfortunately, we are messing it up. And what are the two gases that we are messing it up with by producing in large quantities? Is it A, oxygen and carbon dioxide, B, carbon dioxide and chlorine, C, helium and neon, or D, methane and carbon dioxide? 5, 4, 3, 2, 1. Let me get rid of two answers. First off is carbon dioxide and chlorine. I didn't talk about chlorine, so get rid of it if I don't talk about it. Also, on that note, I didn't talk about helium and neon either, so eliminate those. Correct answer is methane and carbon dioxide. Remember, oxygen is something that we need. Let's review a little bit of chemistry. So I am rewinding this all the way back to September. This is one of the first units that we learned about. And one of the first things we learned about was that all matter, that is anything that takes up space and volume, is made up of particles. We now know these particles are actually atoms. These particles or atoms are constantly moving. No matter what happens, they never stand still. And the speed of their movement depends on the phase state. Do you remember what the 3 phases of matter are? I'm going to review if you don't. First of all, we got solids. Second of all, we have liquids. And lastly, we have gas. So those are our phase trifectas, in case you forgot. Solid, liquid, gas, boom. Let's talk a little more about the speed of particles in our 3 phases of matter. Let's start with a solid. In a solid, I have my particles close together, but still moving. Sometimes we say that they are vibrating next to each other. In a liquid, my particles are a little bit farther apart, but still pretty close to each other. And finally, in gas, my particles are super random and bouncing all over. If I look at this GIF too much, I honestly get a headache. So, the faster particles move, the more energy that they have. And when a substance has enough energy, they can actually change state. Like, for example, if I bump up the energy in a liquid, it will evaporate to the gas phase. So, I want to introduce a vocabulary word to you called thermal energy. And thermal energy is the total amount of energy of motion in the particles of a substance. I think I have a typo on a substance, but whatever, you got it. So I want you to think of it like heat energy. So the goal for today, guys, is to learn about heat transfer in the atmosphere. And I need you to remember that heat is actually the transfer of thermal energy. So we almost have to change the way that we are going to think about heat or what we know about heat. So let me go to the next slide and give you an example. Remember, heat is the transfer of thermal energy, and you and I are really used to thinking like this. We're outside, we're building a snowman, we're touching the snow, and we say, this snow is cold. Or, alternatively, we are holding a nice cup of coffee and thinking to ourselves, this mug or coffee is hot. So, heat is going to flow always, always, always from hot to cold. It's the laws of nature, you can't change it. Always hot to cold. So let's go back to my snowman example. I have my hand, and what is actually happening is the heat from my hand is getting transferred to the snow. So what that feels like is that on my hand, the snow feels cold because the heat is leaving my hand because it's flowing hot to cold and going into the snowball. Let's look at our coffee example. I've got my coffee mug. The heat from the coffee mug is going into my hand. So the heat from the mug is transferred to my hand, and to me, the mug feels hot, but what's really happening is heat is being transferred. It's a little trippy to think about it, but this is what's actually happening. How many times can I say actually? Someone should count. All right, back to the goal of the day. I want to learn about the types of heat transfer in the atmosphere because it's going to happen in 3 ways. The first way I'm going to learn about is radiation. So this is transfer of energy by electromagnetic waves. So we learned about that when we started learning about how the sun's energy gets into the atmosphere. This is actually how a microwave cooks your food. And the key is heating without touching. Okay, so no actual heat or fire touches your food in the microwave, but it still gets hot because the energy is moving up the particles in your food. This is also how you guys get sunburned. Ouch. You don't actually touch the sun, but it can still burn your skin. Okay, next type of heat transfer is called conduction. And this is the transfer of heat between 2 substances that are touching. So we use this a lot in cooking, okay? So if you've got a pot that's nice and hot and you slap on some chicken and right away you start to see the chicken changing colors and sizzling. Okay, heat transfer by physically touching. This is also what happens if you have a metal pan and you leave it on the stove and then you go to grab it and ouch, 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 the heat has transferred to that pan and is now transferring to your hand. Last type of heat transfer that we're going to learn about is convection, and that is the transfer of heat by the movement of fluids. So this is only going to happen with gas and liquids. When I say fluid, I don't mean like water, I mean like that particles can move freely. So what happens is it creates a current or pattern of warm and cold temperatures rising and falling. So this is how it works with your oven, how it cooks your food, and also how radiators warm rooms. So they make this kind of current of hot and cold air rising and falling, and then you put your radiator on, and maybe an hour later, the entire room is roasty toasty. And again, this usually happens with gases, but it can also happen with liquids. Okay, let's end with a quiz. You are cooking at a bonfire after social distancing. You're cooking marshmallows. You do not place your marshmallow in the fire, but it cooks golden brown anyways. This is an example of A, radiation, B, conduction, C, convection, or D, communism. 5, 4, 3, 2, 1. I'm going to eliminate some answers. Conduction, please remember conduction, you have to have 2 substances that are touching. And I said in the text, you do not place your marshmallow in the fire. If you did, it could be considered conduction, but it's not. You didn't do that. I'm also going to eliminate communism because that's not really scientific. I just put that because Exion talks a lot about communism for some reason. Shout out to Exion. You have not gotten in contact with me, but I see that you're working in Schoology. Send me an email or something on the Remind app to let me know that you are alive and kicking. Correct answer is radiation. Radiation is heat without touching, and that's what's going to happen to your marshmallow. All right, guys, relax. I know I'm going to, and I will see you tomorrow. Take it easy.